Today's video is about graphing cosecant and secant functions. Our essential question is, how do we graph cosecant and secant functions using their reciprocal functions sine and cosine? The first thing we want to do is we want to recall our reciprocal functions. Sine of x is equal to opposite divided by hypotenuse, while cosecant of x is equal to hypotenuse divided by opposite. So because their trig ratios are reciprocals of one another, sine and cosecant are reciprocal functions of one another. The same can be said for cosine of x and secant of x. Cosine of x is adjacent divided by a hypotenuse, and secant of x is equal to hypotenuse divided by adjacent. So once again, they are reciprocal functions of one another. Since we already know how to graph sine and cosine, we're going to use their graphs to help us to graph cosecant and secant, respectively. Go ahead and pause and copy down this section of the notes, and then we will continue with two examples. Example number 1. We want to graph f of x equals -1/2 cosecant of 2x minus 3. We want to determine the amplitude, the period, the phase shift, vertical shift or midline, and the asymptotes. And we want to be sure to graph the asymptotes and the midline when we make our graph. Now, because cosecant and secant are not going to be continuous graphs, we are going to have asymptotes, and we'll talk a little bit more about how to find those in a couple of minutes. So first thing we have to do is label our parts of our graph. The A number, the coefficient in the front, is -1/2. Our B number, our multiplier, our coefficient of x, is 2, and we don't have a C number inside the parentheses being added or subtracted from the x term, and D is -3. From that, we're going to determine our amplitude. Amplitude is the absolute value of A, so the absolute value of -1/2 gives us a +1/2 for our amplitude. Also note that because A is negative, we will have a reflection over the x-axis. For the period, we have 2 pi divided by b, just like for when we were finding the period of sine. So it will have the same period. So as we are working on 2 pi divided by b, we're going to take 2 pi and divide by 2, and so our period is pi. Now remember, that means that we will have a complete cycle by the time we get to pi. For the phase shift, we have, again, no C value up here, therefore our C is equal to 0, which means there is no phase shift. So remember, our phase shift is C divided by B, but if we have C being 0, 0 divided by 2 is 0, so there is no phase shift. Vertical shift is our D number. Our D number is -3. So we are going to be shifting down 3, which also means that our midline is located at y equals -3. And then last but not least, we need to talk about our asymptotes. Our asymptotes are going to be located at bx minus c equals pi times n, where n is an integer. And we really only need to determine 2 asymptotes, because once we find those 2, the rest of them will follow that same pattern. So first thing I'm going to do is plug in what my b and my c are. Or basically, you're just taking the information that's in the parentheses up here, and that's what your bx minus c is. So take the 2x and set it equal to pi times n. N can be whatever integer you want to choose. So easiest thing to do is choose 0 and 1. So I'm going to choose 0 as my first number that I'm going to use for my asymptote. Pi times 0 is 0, so 2x is equal to 0, and then I just finished solving that by dividing by 2. So x is equal to 0 is my first asymptote. Now I'm going to do my second one. Choose another integer. The next easiest integer I can think of is 1. So I'm going to take bx minus c, which is 2x, equals pi times 1. And then I'm going to simplify that. 2x is equal to pi. Divide by 2. X is equal to pi over 2. So my first two asymptotes are located at x equals 0 and x equals pi over 2. So I'm going to go ahead and start sketching my graph now. But before we do that, why don't you pause and finish copying down this information, and then we'll come back and do the graph. Okay, back to the graph now. Remember, the first thing we always do is graph our midline. Our midline is located at y equals -3. So let's go ahead and plot that. Remember, that's a dotted line, just helping us to locate our, to start our graph. So here's our midline. Next thing we're going to do is let's go ahead and graph our two asymptotes. Now before I can do that, I need to know what our period was. Our period was pi. So remember, by the time we get to pi, we will have completed one cycle. And remember, just like with our sine graphs, we always wanted to break it into 4 sections, 4 equal sections. So I'm going to take pi and I'm going to cut it in half. So this is pi over 2. And then I'm going to cut those in half again. Again, equal sections. So this is pi over 4 and 3 pi over 4. This is going to help me to break my sine graph, because remember, we're going to base this off of the sine wave, into 4 sections. Remember, the sine wave is like a snake, so it's where it's crossing the midline. We have 3 points where it's going to be crossing the midline. Now let's go ahead and plot very quickly those asymptotes. We've got x equals 0, so right here on x equals 0 we have one of our asymptotes, and then we have our second one at pi over 2. Now, you see how far apart they are? Every pi over 2, I'm going to have a new asymptote. So I can draw another one over here at pi, and I could continue and make, as I make my graph a little bit longer, at 3 pi over 2, I would have another one. It just follows the same pattern over and over and over again. Now, once I've done that, now I can start plotting my points. I have a point. Remember, the sine wave has 3 points on the midline. The first one, the middle one, and the last one. So right at, on the x-axis here, we're going to have our first point on the midline. We're going to have our next point on the midline. And that one's going to be halfway. Now we're trying to go all the way to pi. So our third point is right at pi. So remember, halfway was at pi over 2. And now we're ready to get our amplitude points. Now remember, on this one our a was negative, so it's going to be upside down. So instead of going up for our first amplitude point, we're going to go down this time. And our amplitude is 1/2, so I'm going down 1/2 of a box, and that's halfway between 0 and pi over 2 at pi over 4. And then halfway between pi over 2 and pi, I will have my second amplitude point. And this is my sine wave. It's helping me to get my cosecant wave, or my cosecant graph. So I really just want to make a dotted curve and continue it around. I do not want to make it solid because this isn't the actual graph itself. It's just helping me to get my cosecant. Now, once I've gotten my sine wave on there, now I'm ready for the cosecant graph, which is just I go to where the sine waves are, where the lowest point is and where the highest point is. Right at the lowest point, I'm going to make a U-shaped graph going the opposite direction. Because remember, it's the reciprocal, so I want it to flip. So I now go to the highest point, where the highest point of the wave is. I make another little U-shaped graph, staying inside the asymptotes as I go. Go to the next lowest point, make a U-shaped graph going the opposite direction because it's the reciprocal. And again, always staying inside those asymptotes that we have drawn every pi over 2. And then last but not least, I go over to the negative side. I do the same thing. I go over to negative pi over 2. The graph has continued on this side, just following that same little pattern up to negative 2.5. And I draw a little U shape, the reciprocal, so it's flipping up and then flipping down again on the other side of that asymptote. And this is what your cosecant graph looks like. Now, a couple of points to make. I want you to notice that your asymptotes, I'm just going to abbreviate that, asymptotes are located where the sine wave hits the midline. And you're going to notice that same thing to be true when we come down here and we graph the next one, which is for the secant. The asymptotes will, on the cosecant graph, the asymptotes are always located where the sine wave hits the midline. And for the secant graph, the same thing's going to be true. It's going to be located where the cosine graph hits the midline. Alright, go ahead and pause, finish copying this, and we'll finish up with the second example. Okay, example number 2. F of x is equal to 2 secant times x minus pi over 2 plus pi. We want to determine the amplitude, period, phase shift, vertical shift, midline, and asymptotes of the function, and then graph it. So we've got 2 secant of x minus pi over 2 plus 1. So first off, our amplitude is the absolute value of a, so we have the absolute value of 2, which is equal to 2. No reflection on this one because a is positive. Period, 2 pi divided by b, so we have 2 pi divided by our b value is this, on this one is 1. So 2 pi divided by 1 is just 2 pi, so we have a period of 2 pi. Phase shift is c divided by b. Our c is pi over 2. Our b is 1. So our phase shift is pi over 2 divided by 1, which is pi over 2. And because it's positive, we're going to be going to the right. Vertical shift is d, which is 1. So we're going to be going up 1 with our vertical shift. Our midline is y equals 1. And our asymptotes are going to be bx minus c equals pi over 2 times n. Notice there's a little bit different location on the asymptotes. where n has to be an odd integer. So for the first one, I'm going to pick my first odd integer. I'm going to use positive 1. Pi over 2 times positive 1 is just pi over 2. Bx minus c is what's in parentheses up here in our equation, which is x minus pi over 2. So we're going to have x minus pi over 2. And to solve this for x, I'm just going to add pi over 2 to both sides. And we're going to get pi over 2 plus pi over 2, which is just pi. So there's my first asymptote. Second asymptote, the next easiest odd integer to use is -1. So I've got x minus pi over 2 equals pi over 2 times -1, which is negative pi over 2. I'm going to add pi over 2 to both sides. When I add pi over 2 to negative pi over 2, I get x equals 0. So this is the two locations for our asymptotes. Again, just like on sine, find two asymptotes and then they will always follow that same pattern of distance between them. Alright, pause, finish copying this, and we'll finish up with the graph. Okay, finishing up with the graph. First thing we're going to do, just like before, let's graph our midline. Our midline is located at positive 1. So here's our midline coming across here. Next thing we're going to do is look at our period. Let's go ahead and mark that off. The period is 2 pi. Just like before, we divide it into fourths. So we have half of that is pi, half of pi is pi over 2, halfway between pi and 2 pi is 3 pi over 2. Remember, for the cosine graph, it's a chalice. These 2 points are starting up at the amplitude. This point is at the bottom with the amplitude, and then you have 2 points that are on the midline. So let's start with our amplitude points. Our amplitude points are up at, our vertical shift was 1, our amplitude was 2, so we're going to be 2 above our midline. Also remember, we had a phase shift. Normally our cosine would start on the y-axis, but because we have a phase shift of pi over 2 to the right, it's going to start right above pi over 2. So if I go up 2 above the midline, I'm going to be starting at positive 3. That's my first amplitude point. My last point of my cosine curve is at the end over here. But because we shifted over pi over 2, instead of being at 2 pi, it's going to be at 5 pi over 2. So there's the end point of my period of my cosine wave. And then I also have my lowest amplitude point, which is halfway between those 2 points at 3 pi over 2 and at -1. And you can see the marks are a little bit off. And then remember, these points that are halfway in between our amplitude points are the ones that are on the midline. So I'm going to have a halfway point at pi and another halfway point at 2 pi. So now I'm ready to sketch my cosine graph. Remember, I am putting the dotted line because this isn't the actual graph. I'm trying to graph secant, which is the reciprocal of it. So I have my cosine wave going. You probably want to go ahead and extend it a little bit. We would have another midline point at 0 and another lower amplitude point at negative pi over 2, and then another midline point at negative pi. So we can just extend it a little bit so that we can see get the full picture of what our cosine wave looks like. Now that I've done this, I'm ready to sketch in my asymptotes. The asymptotes are located at pi. And 0. And if I continue that pattern, they're also located at, notice this has a distance between them of pi. They're also one located at 2 pi and another one at negative pi over on the negative side. And then we continue in that same pattern from negative infinity to infinity, but we'll stop here. Again, just like with the sines, notice that the cosine asymptotes, an easy way to check to see if you're right, the cosine asymptotes will always be at the same locations as where the cosine wave crosses the midline. So they're in the same places as just like with the sine wave. Once I've done that, now I'm ready to draw the actual secant part of the graph, which is the reciprocal of the cosine wave. And so at each one of our low points of our cosine wave, we have the upside down U shape, and at each one of our peaks or our high points of our cosine wave, we have a little U shape going the opposite direction and staying again within the asymptotes, just like on the sine wave. Remember, cosine and sine are very similar to each other. They're just a phase shift one of the other. So if you will finish copying this little graph, and we will see you tomorrow in class. Have a good evening.